Okay, today we're going to look at some problems involving derivatives of log functions. And just over here, remember, if we have y equals the natural log of x, y prime is 1 over x. And if y equals the natural log of u, y prime equals 1 over u times du dx. So there's our chain rule. Okay, so here again we have a composite function. So y prime is 1 over the sine of x. And I'll write it over here times the derivative of sine x, which is cosine x. So that gives us cosine x over sine x, and that simplifies to cotangent x. Okay, now our next problem, we have the square root of the natural log of x squared. So again, we have a composite here, and I'm going to rewrite this as the natural log of x squared raised to the 1/2. And so that's going to give us as our derivative, I'll do this a little bit the long way, we'll talk about some shorter ways in a little bit, 1/2 the natural log of x squared to the negative 1/2 times, now we do the derivative, what's inside, so we have the derivative of the natural log of x squared. So 1/2 the natural log of x squared to the negative 1/2. So here we would have 1 over x squared times the derivative of x squared, which is 2x. All right, so in simplifying, the 2's divide out, x divides out, so we're left with an x in the denominator, and we're left with 1 over, and then we have x from here, and then here is the square root of the natural log of x squared. Okay, moving on to another problem here. So here we have problem number 3. And this is one that I would actually use our log properties to simplify this. I do not want to take 1 over this argument here times the derivative of that, and that's going to get complicated. So anytime we can apply our log properties, and I was talking about some shortcuts earlier, we can apply that here. So this is the natural log of x plus 1 minus, because we are dividing, the natural log of the square root of x minus 2. Now remember, the square root of x minus 2 can be written as x minus 2 to the 1/2. And so if I do that, and now I can apply our power property, and that would give us the derivative of the natural log of x plus 1 minus 1/2 the natural log of x minus 2. So significantly easier problem. So now I take the derivative of the first term, which would be 1 over x plus 1, minus 1/2. The derivative here is 1 over x minus 2. And there's our derivative. Way simpler than if we had tried to apply that right from the beginning. Okay, so let's derive our log derivative when we're talking about something other than base e. So I have the derivative. I'm going to rewrite log base a of x as the natural log of x divided by the natural log of a. That's our change of base formula, or one of our change of base formulas. Right, this could be the log base 10 in the numerator denominator. So now we have the natural log of x divided by the natural log of a. Well, a is a real number. Specifically, it's a number greater than 0 and not equal to 1. So the natural log of that real number is also a real number. So this is really a scalar. So that means that we can pull that out in front of our derivative. So now we're back to the derivative of the natural log, which is 1 over x. And so combined, this would be 1 over x times the natural log of a. Okay, so how do we apply that? So here we have a log function with base 10. So that means that the derivative of this is going to be 1 over the natural log of 10 times 1 over the derivative, or 1 over the argument rather, 1 plus or 2 plus cosine x times the derivative of the argument. There's our chain rule, right? So again, going back to our previous problem, right? Log base a of x, there's our log base a of x, 1 over, and so that's our x, that's here. There's our 1 over the natural log of a. So continuing here, the derivative of this, so we'd be left with 1 over the natural log of 10 times 2 plus the cosine of x. The derivative there, 0 plus the negative sine x. So I'm going to erase our 1, don't need that, and we're just going to have negative sine x. Okay, last problem. Use logarithmic differentiation. So what that means is we're going to take the natural log of both sides of the equation, and then what we're going to do is we're going to apply our log properties. So we have 3/4 x. We're multiplying here, so we add, and then we have 1/2 the natural log of x squared plus 1. And then we have minus 5 times the natural log of 3x plus 2. So a lot going on there. And so now we're going to take, so again, natural log of x to the 3/4, power rule, product rule here, so we're adding, and then again a power rule, the 1/2, quotient rule because we're dividing, and then 5 here because of the power rule. So we're going to do differentiation. So the natural derivative here on the right would be 1 over y times y prime equals, here we'd have 3/4 derivative natural log 1 over x plus 1/2. The derivative here is 1 over x squared plus 1 times the derivative of that, which is 2x, minus 5 times 1 over 3x plus 2 times the derivative of 3x plus 2, which is 3. Okay, last step, y prime equals, so we're going to multiply both sides by y, which is this, right? That's our y, so we have x to the 3/4 times the square root of x plus 1 over 3x plus 2 to the 5th. All of that times here, 3 over 4x. Here our 2's divide out, so we're left with x over x squared plus 1 minus 5 times 3, 15 over 3x plus 2. So there's our logarithmic differentiation. Hope this helps, and we'll see you soon.